I'm not sure if it's true that everybody knows me, so I'm going to assume that some of you at least don't know who I am. So mainly, I'm a Python and JavaScript developer in recent years. I've been living in Ireland for the last 5.5 years. Currently, I'm a principal software engineer at Elastic, working on search, the search product. I have a blog, this blog that apparently some people know about. So you're more than welcome to visit it. And there's also a bunch of books that happen to have my name on the cover. And the most recent one is actually about the topic of this presentation, SQLAlchemy 2. The book is an introduction for beginners. This is not an introduction for beginners. This is a description of what's new in version 2. So let's get into it. So I'm going to start with the main thing. So when you leave this presentation, if you are going to remember one thing about SQLAlchemy 2, it should be that it has a much better integration with type checkers and with IDEs, which used to be a pain point. I'm sure some of you, if you worked with SQLAlchemy pre-2.0, you probably remember horror stories of not being able to get PyCharm or VS Code to return a clean bill of health for your project. So what I'm going to do to show you this, before I describe anything, I'm just going to give you a quick demo of how things look like. I have a problem. I don't want to get half this room mad at me because I selected the IDE of the two that is not your favorite. So instead, what I'm going to do is I'm going to upset the whole room, and I'm going to show you how this looks in Vim. Okay? And then, there you go. So this is an example project, and if you look at this, you may think that this is this nice piece of code, but what's missing here is that there are no warnings or messages about incorrect types or anything. So you may think that types are disabled here. And the fact is that they are enabled. And this file with a bunch of SQLAlchemy models is fully typed, 100% typed, and doesn't give any errors or any warnings or anything. So that's the main thing that you need to take away from this presentation. And then later I'm going to go into the little details. You're going to see things here that you don't recognize if you've used the previous version, the 1.x versions, and I'm going to go into that. For now, let's ignore all that, and I'm going to find, so let's say customer, so this is a model, an example. So because you don't have to believe, you don't have to take my word for it, I'm just going to go and go ahead and mess this code up. So I'm going to remove this number. Oops. Oops, what's going on here? There you go. So, and right there you can see that Vim, of all things, is telling me that this is not correct. Okay, so the whole thing is like that. This can be a blessing and a curse, as they say. SQLAlchemy is a fairly complex framework. So, for example, if let's fix this before I keep going. So if, let's say, you're writing a relationship and you want to know, what arguments you can take. You do this and whoa, But, you could argue it's better to see this mess than not seeing anything, right? Which is what it used to be pre-2.0, right? So now you get a ton of information. Sometimes it's too much. The type of experience that you can get is something like this. So I'm going to write a quick query just so that you see how things look. So this is a customer. So I'm going to do a last order, for example. So self, and here you can see that I get all the suggestions. So orders is in there. Okay, never mind this type that I'm going to talk about that later. So this has a bunch of things. They all come with help. So I'm going to do a select statement here. And then, this is a select. So all the select things, order. So I'm going to sort. I have an order model, which has timestamp. It's right there. It's a datetime. So, and I want to do the last, so I have to sort descending. So here, there it is, with help and everything. So you see, this is, ages, miles away from the experience that used to be the case if you worked with SQLAlchemy before 2.0. Okay? So let's go back to the boring part. So I'm going to describe all these things now, or at least some of them. There's a new way to define models in 2.0. So something that I'd like to do, you don't have to do this, but the SQLAlchemy package has a long list of things that you can import. And if you import them individually, you end up having a long list. So something that I adopted recently is to basically get SA is SQLAlchemy, and then SQLAlchemy.orm is SO. And this gives me access to all the things that I need to work with SQLAlchemy. So starting from this, you can define a model, which is the base class for all your database models, by inheriting from this thing called declarative base. Previous versions used to have this as a function, so this was super weird. You have to create a dynamic class, and I see people saying, yeah, that was weird, right? So now it's a class, and you inherit from it, and then you create your models as subclasses of your main class. SQLAlchemy likes to call this base. I like to call it model, so here I'm using model as my base class. So then your model will have attributes, and older SQLAlchemy, you had to use this collection of types that came with SQLAlchemy, and now that's all gone, and you can use type hints from Python. So the only difference between normal type hints is that for this you have to use this mapped generic type from SQLAlchemy. So you wrapped your type, your Python type hint with the mapped generic type. And here we have 3 examples. The first 2, an integer and a string. The third one is an integer that is marked as optional, which means that it's going to be nullable in database terms. The other 2 are non-nullable because I did not use optional. So sometimes this isn't enough. You have to tell SQLAlchemy more things about some of these columns. So for that, you can use this mapped column function that you assign to each field or each column. And then you pass the additional things that you need to use to configure the column as arguments. In the first case, for ID, you're telling SQLAlchemy that this is a primary key. On the second one, you already you declared it as a string, but the type doesn't have a way to give the length, and some databases, not all of them, but some require length. So in that case, you can go back to the SQLAlchemy type and give it the length. There's also another way that I didn't put here. I mean, if you're a fan of types, if you like to build types and assemble your own types, there's a way for you to define, for example, an str50, right? And then you don't have to do this. You define it somewhere else, and here you put str50. And then you will not need on that particular one to add the mapped column thing. So this is optional, and something that I personally don't use myself. but there's a way for your model to be converted into a data class. If you're using data classes in Python, this is a very specific thing. If you don't know what it is, then this isn't for you. But if you do know what a data class is, you can make the model be a data class. And with that comes some benefits. And you can see here, I'm giving some data class specific things. On the ID, I'm saying that this is not an attribute that needs to be initialized. So it's going to be removed from the constructor with this. And then for age, I'm giving it a default. So all these things, what they do, if you're interested, what it does, it creates your constructor. When you create an instance, it gives you all the typing help. If you don't do this, then the constructor for your models is going to be a generic keyword arguments. It can be anything. So if you're really into types and you want everything to be typed to the dot, then this is for you. So that was for models. So new way to define models. There's a new way to define queries as well. So using the same imports, one thing I think it's fantastic is that in SQLAlchemy 2, the queries are completely separated from the execution of queries. So this is a query. You can see that I didn't define a database. There's absolutely nothing here that ties me to a database, but I can build a query. Okay? So the query is built in Python. It's a Pythonic representation of what the SQL statement would be. It's actually very close, much closer than before. And it's completely independent of any databases at this point. So if you want to execute this query, you first have to create an engine, and this is the same as before you created the engine. And this is basically the driver that connects your application to the database. And then you have two ways to execute the query. You can get a connection to the database from the engine itself. But if you're using models and the ORM features, you probably create a session. And sessions are also using a new syntax in 2.0. It used to be that you used all these weird mechanisms to create sessions, scope sessions, all these things. And now you use a context manager, which is actually, in fact, in 1.x releases, I built my own context manager to work with sessions because it's what makes the most sense. You want the session to be created, you do whatever you need to do, and then at the end it's clean up for you, right? You don't have to do it. So they now adopted this. So you create a session, and then in the session you execute the query. So this allows you to build. You can have a module in the same way you have a module where you have your models. You can have a module where you have your queries, and then you can have your execution completely separate and independent. So when you execute a query, you get an iterator as a result. One option, you can iterate on that thing if you want. If you want to get the results as a list, you can ask for all the results, and then it's going to be a list of tuples. It's going to be tuples for each row of results. You can get the first, if that's all you're interested in. You can get one, and this is nice because if the query returns 0, 2, or more, you get an exception. So basically you're saying, I want one and only one. And if it's not one, error. And then there's one that allows one or none, but doesn't allow more than one. So all these ways to get the result. I mentioned that each result row is a tuple. This is because when you do a select, usually you can put a list of things. But in many practical cases, and this is the case in this example, you put one thing there, so it doesn't make sense to get a one-element tuple. So instead of using execute, you can use scalars for executing the query, and then that will give you the first result of each row and throw away. If there are any additional results, it will be thrown away. So you use this when you know that you're going to get one element per row. And then, like before, with the execute, you have all first one and one or none to work with those results. There's yet one more called scalar, which is the singular version of the previous one. It gives you only the first element of the first row, and it throws away everything else. So basically, you have all these options to get your results, depending on what you expect or what you need. So to add an element, a row to a database or to a table, this hasn't changed. You do session.add and add the object, and then you commit the session. Something that's new that I also like a lot, I find myself when I use this format, I end up putting commits all over the place. And if you initialize the session with the begin method, then the session will be automatically committing for you when the context manager block ends. So this commits at the end if there are no errors. And if there are any errors, it will roll back the session and do everything to clean up the mess so that you can continue after this without any issues. So on relationships, there's also changes. So here is an example. We have a one-to-many relationship between users and addresses. One user can have many addresses. So you put a foreign key on the address side. So you use type hints for this as well. So mapped int is how you define this. And int needs to match the type of the primary key on the other side. So this is going to be the type of the ID element in the user table. And then in the mapped side, the mapped column side, you add the foreign key. Then you can create your relationships. And these are a high-level view of this relationship between these two models. And if you look at let's look at the address side first. At the bottom, you have user. User is typed as a user object. So it's essentially what it is. It's typed correctly. And then on the user side, you have addresses, which is typed as a list of address elements. So completely natural. It's what you expect. And then the relationship call has this backpopulates that each one gives the name of the other one, because these two are the same relationship as seen from the two sides. And this is how SQLAlchemy knows that these are the same relationship. So how do you work with this? You create a session. You call session.begin if you want an auto commit at the end. And then inside, if you have an address, you can say address.user, and that's a user, and it's fully typed. You can say from the other side, user.addresses, and that's a list, a regular Python list, good old list. And if you want to add an address to a user, user.addresses.append, exactly, you use list semantics for everything. And then this is going to be committed at the end, so you don't even need to do the commit. So this is all good. There's one other type of relationship that's new in 2.0. That's called write-only relationship. And so here, there's a problem with some relationships. Going back to the example with user and addresses, a user would probably have, I don't know, 1 or 2 or 3 addresses, no more than that. So it's fine to have a list of them. Imagine there might be a case where the relationship can have a long list. Like the list could be, I don't know, let's say this is a supermarket where a user that goes there to shop, every week, over a year, it's 300 orders, right? So you would not want usually to have access to all 300 at the same time. It would be wasteful to request all of those when maybe you care about the last one. So write-only relationships are, they fulfill this need of having a relationship that you need to modify, you need to add or remove elements from it, but you don't want to load it every time, and you are not interested or may not be interested in the whole relationship, the entire list. So the way that works, on the bottom, the user side, the user relationship for order is exactly the same, no changes from the previous one. Then on the user side, orders is, it gets this alternative type, which is write-only mapped. And this is telling SQLAlchemy that this relationship should not be loaded. It should only be used to add and remove, but you should not load it. So how do you use this? If you want to add an order, you just do orders.add, and that does it, even though user.orders, in this case, is not a list. It's not something that you can use to get the relationships directly. If you do need to get the relationship, you can use user.orders.select, and that returns a query. And once again, separation queries are separated from the execution, so you get a query, standalone query that you can modify. In this case, I added a limit of 2, and then I run the query in the normal way. I run all the queries, my queries, and that's how you get your the elements of this relationship. So you may be worried that this is too different from what you know, and that it's going to be painful to migrate. So I think they've done a pretty decent job, way above the average for most Python packages. In general, most of the things that you do, unless you do something obscure, all the things that you do with the 1.x releases will work because they have not deprecated or removed anything. So all the old ways of doing models and queries and relationships are still supported. I don't believe they're planning to remove them. At least they didn't say anything to that effect so far. So chances are your code will work on 2.0 with very minimal changes or no changes. The problem is if you leave that code that way, you're not going to get the benefits. So the typing it's going to continue to suck when you use the old interfaces through models and queries and relationships. So to take advantage of the new stuff, you have to migrate. SQLAlchemy 1.4 is sort of a bridge between the 1.x and 2.x releases. It has some features that came with 2.0 included. There are early releases of them. And it also has a bunch of warnings about things that changed or that they do plan to be removed. There are minimal. There aren't that many. So it's not really a huge deal. So the migration path will be to upgrade to 1.4, the latest 1.4.x that you can find. Make sure that you run your application, all the tests pass, everything works. You get no warnings, no deprecation warnings or any sort of warnings. And then once you reach that point, you can upgrade to 2.0, and likely you will not need to change anything else. And the code will work. And then once you have your code on 2.0, you can start migrating your legacy code. Take your time, upgrade the parts that are more interesting to you first, and take your time and get it. Over time you will get it all upgraded to 2.x and get all the fancy typing and all the new stuff. Another big thing with SQLAlchemy 2 is that they added support for async I/O. So now you can use this with Fast API or any regular async applications that you write that are not web applications or whatever else. The good news is that the models are defined exactly the same. The queries are defined exactly the same. And the only thing that changes is how you work with engines and sessions. And the change is that you have to use async interfaces for those. So you have to use a asynchronous database driver. So for example, AIO SQLite, AIO MySQL, Async PG, or others. These are examples. They're not the only ones. There's a bunch more. Instead of calling create engine, you call create async engine. Instead of using session, you use async session. You use await anytime you make a call into a database that can be blocking. And this may be a bit obscure. Instead of execute and scalars, there's two versions, two alternative versions called stream and stream scalars that are that use asynchronous iterators instead of regular iterators. So if you want fully async, you use the stream versions. And finally, the one that is going to be completely obscure. And when you start working on a migration, you will say, okay, now I understand. SQLAlchemy has this thing where in many cases it preloads relationships automatically. Going back to the example of users and addresses, we say user.addresses. That implicitly triggers a query. It runs as part of that expression, and that brings the list. And that is a behavior that doesn't work with async because it's blocking, and because this doesn't have an await, it cannot work. So you have to rework your code so that there are no implicit queries ever. And this is a bit tricky. It might be the most tricky thing that you have if you want to use async with SQLAlchemy. So then there's this thing called Alchemical. This is a package that, full disclaimer, I wrote. So this is self-promotion. So the idea is to eliminate or reduce the boilerplate when working with SQLAlchemy. So you always have to create an engine and create the session and configure it. There's a good recommendation is to set up naming conventions for your constraints, which may bite you if you don't do it when you work with migrations. So it basically wraps all these things into a single call. It integrates with Flask, Fast API, or anything else. It's framework agnostic, works with sync or async, SQLAlchemy. It can allow you to use Alembic for database migrations in a way that is easier than if you do it yourself by hand. And it also allows you to work with multiple databases in a single application, which is very difficult. It's doable, but very difficult with SQLAlchemy. So this, you pass a list of your URLs, and with a single object, you manage 2 or more databases very easily. So here's an example. So from Alchemical, import model, and that's your model base class. The query is exactly the same, but if you want to select one thing and it's a model, you can say user.select. So you save an import right there. You create a database by creating an Alchemical object. You pass the URL. As I said, if you want to work with multiple databases, here you pass a dictionary with them. Create all will create all your tables if they're not created already. And then db.session gives you the session. And then uses the same context manager interface. But all the setup is gone. And in addition to the normal things, it also does your naming conventions, and it leaves you ready to use Alembic if you wish, and all these things. Here's an example that uses the async Alchemical interface. The difference is that you import from alchemical.aio. The model is the same, the query is the same, and then create all, and the session and the scalar call, all the blocking calls are awaitables, so you have to use await. The context manager is an asynchronous context manager, so basically all natural, right? And it's actually very easy to migrate to async, much easier if you do it with Alchemical. So if you want to see examples, on my GitHub, there's this repository called RetroFun. this is the code from my book, and you can find examples going from the simple to the not so simple that you can look there, including an example application, a complete application with Flask, and the same application with Fast API, coded with the two frameworks. If you want to see something that is not so simple, I recommend Microblog API. This is a backend project that uses SQLAlchemy 2, Flask, Alchemical, Alembic, and also has open API documentation. So really, production scale type project, completely non-trivial if you want to see how things look in something made for the real world. This is, I dog food everything, by the way. This is the project that I use as a backend for my React book. So people who follow the React tutorial use this as a backend. It's a real project that you can use. And there we go. That is it.
Do we have any questions here?
There's plenty of time, right?
Yeah, 5 minutes. Yeah.
I see lots of programming improvements, Miguel. Have you made any performance improvements as well in SQLAlchemy 2?
I wouldn't say so. No, I think the performance improvement, for example, comes from switching to async. So you can use async PG, which is actually very performant.
Okay.
So switching to async might be the way.
That's the way. Thanks.
Yeah.
Any other questions?
Do you have an approach or preferred approach for model generation from existing database models, like stuff that's not originated from Python code, but is coming from an existing DB?
Yeah, I don't have to have a preference. SQLAlchemy supports this.
Sure.
There's I believe it's called model. I don't do this, by the way, myself, but it's called model reflection. So you can reflect. So you open an engine and point it to a database, and then you have this metadata instance. I don't know if it makes sense, if you know what that is, but it's one of the internal things.
But does that give you the typing information that you described here, where you can get static type analysis?
That will probably not give you typing information.
But there's like an SQLA code gen package that actually writes out a model file that you can then statically analyze, but I don't think it's anywhere near as advanced as the typing.
You probably have to wait for that library to basically to adopt this new style of writing the models. If I had to do this myself, I would not use the reflection from SQLAlchemy. I will do a generation. If I didn't know this, but if there's a package that generates models automatically, that's actually great, even if it's not perfect. You generate the models. Maybe it's old style, but then you can migrate it to the new style that I showed here, and then you do get full benefits, of all the typing.
Yeah, although the real advantage is being able to generate the models afresh every time the database changes, so you don't want to necessarily hand edit them either.
Okay, so in your case, someone outside of your application will still own the database and will continue to make changes to it.
Yes.
Yeah, stuff. Yeah.
Any other questions? Right. Oh, we have one.
Sorry, just a quick question was, do you always use the ORM whenever you use SQLAlchemy? Do you ever use just the core layer on its own?
Right. So I personally do. I do like the ORM. I know a lot of people don't, which is totally fine. You're not going to get the full typing experience if you use the core module alone, right? A lot of the effort was put into defining models with types, right? And that's all gone, right? You don't do any of that, right? When you use core alone. So yeah, that's the downside, I guess, which doesn't affect me because I really like to work with Python objects more than thinking in terms of database. I prefer to forget that I'm using a database as much as possible. So it works great for me, but I realize it may not be, great for everyone, right? You may still have some pain if you work with core alone.
Thank you. Brilliant.
So, yeah. So that's it. Thank you. Thank you, Miguel.
Thank you very much.